Carpe Diem VPN. Seize the network.
Hey everyone, this is Tim with Carpe Diem VPN, and today we're going to do part 2 of the SD-WAN lab overview and design considerations. In the first video, I talked about some of the design stuff we'd have to solve in order to rebuild this lab and kind of apply that to real world. And in part 2, I'm just going to cover some of the other things we need to solve long term and just figure out how we're going to deal with some of these issues that come up so we can move on to rebuilding this lab. Quick refresher, in this lab we have 2 data centers connected over a DCI. We have 3 different kinds of transport. Our SD-WAN controllers are up in the cloud. We have a legacy site that's not SD-WAN but requires the ability to talk to SD-WAN sites and vice versa. And we have 3 different types of SD-WAN site to give us some different options from a design perspective. All right, so let's go ahead and move on to the next topic. Okay, so let's talk about legacy integration. What I mean by legacy integration, of course, is the ability for non-SD-WAN sites to be able to talk to the SD-WAN and vice versa. So let's take a look at our setup here. All right, in this diagram, we've taken just a slice of the network to illustrate what's going on. So we have our legacy site connected only to the MPLS cloud. And then, of course, we have our SD-WAN, and our data center SD-WAN boxes are connected to all 3 transports. Now, of course, there's 2 data centers, 2 routers per data center, so there's really 4 different routers, but I didn't include all of that here because it would get a little messy. So, and it's basically the same for all of them. So let's kind of go through here and see how connectivity will work under normal circumstances or under the options that we have. And then we'll explore maybe one of the other options that we could use to provide that crossways connectivity. Let me see if my pen works here. All right, so let's say our legacy site is, I don't know, just give it a number for now. We'll just say 10.99.1.0/24. And those are the user prefixes or data prefixes for the legacy site. Now, under normal circumstances, when there's no SD-WAN, of course, this legacy site just advertises those prefixes to the MPLS carrier, and then the MPLS carrier, of course, will advertise those prefixes on to the customer's other routers for connectivity. Now, in this case, the SD-WAN router will actually get the advertisement from the MPLS cloud if they both are paired with BGP. And you'll see later that it's not necessarily required that the SD-WAN routers actually peer with an underlay device. Under certain circumstances, we could just use a default route or something like that to point it at a certain transport. But in this case, in order to get the legacy prefixes, we actually have to peer on the underlay or non-SD-WAN, if you will, the VPN0 interface. We would have to peer BGP with the provider to receive those prefixes. Now, one of our options to get those underlay prefixes into the overlay or into the SD-WAN or specifically into, say, VPN 10, which we'll say is our service VPN. We have a couple options there. One is that we could do a policy. We could do an SD-WAN policy that does basically route import export. So if you're at all familiar with MPLS Layer 3 VPN, then this concept should be pretty simple. Right. And so what we're going to do, or what we have the option to do, is to import routes that receive in VPN 0 and then leak them into VPN 10. Or, vice versa, to get the routes from, say we wanted to take the routes from the SD-WAN overlay and inject them into the MPLS and get them to the legacy site, we could export them in the same fashion, go from VPN 10 to VPN 0. Now what you'll see is, based on our design, how we set it up, that may not be required. So we could do an aggregate or a default route or something like that down to the legacy site. We don't necessarily have to do route export from the VPN service VPN side or VPN 10 into VPN 0. So it's a lot of design consideration there. That's something that we will dig into much more deeply when we start talking about this topic, in detail. So that's one of our options, is that we can use our SD-WAN control policy to do route import export. And what that will do is ultimately advertise this 10.99 to the overlay SD-WAN. So that would then, of course, get advertised to the DC core. And also over, it would get advertised to the vSmarts, and then the vSmarts would advertise it over the correct transports to our SD-WAN branches. So that would provide one-way connectivity. And of course, to get back, you can imagine that, and I don't remember the prefix that I've selected for branch 2 here, but it might be something as simple as 10.20.1.0/24. Of course, the branch router is advertising to the vSmart this prefix, and then and so the vSmart is then advertising with the DC1, and we could export that route into VPN 0 and then advertise it to our provider, which of course would turn around and advertise it to our legacy site. Some of our other options are we could do no route export, but we could advertise a network, maybe an aggregate network for the entire SD-WAN. It depends on our network design, how much flexibility we have with our IP schema. A lot of these are going to be brownfield, especially type of migrations. So, if we got lucky enough to be able to roll up all of our SD-WAN sites into some supernet, we could just, create a static route to null 0 and inject a network into BGP, and that would be another option, right? So there's a lot of options here, and there's a lot of things that we'll dig into more and kind of try to decide. And there's no one best answer here. A lot of this is going to be informed by the current network design of both the SD-WAN and the legacy sites. But let's table that for now and just talk about one of the other, some of the other options we would have to do this two-way connectivity between legacy and SD-WAN. So let's move on to the next option. So another option we have is to drop or use a non-SD-WAN router in the data center and connect that to the MPLS. So we talk about brownfield or migration strategies and whatnot. This is probably what already exists today before there's an SD-WAN. So this router could be repurposed to still provide that MPLS connectivity, right? And so, the same setup would apply where the legacy site would be 10.99.1.0/24. It would advertise that to the MPLS cloud. Cloud would advertise that to the SD-WAN, the non-SD-WAN router, and then what the non-SD-WAN router would do is redistribute or just advertise in some fashion those prefixes to the DC core. Now it's on the service side. Basically, this non-SD-WAN router has taken the service routes or the data routes from the legacy site and injected it into the DC1 core. And it's on without there being any kind of VRF segmentation or whatnot, we've now injected this route into the service side, because the DC core will advertise those routes or that route to the SD-WAN router and in the service VPN, whatever the service VPN is that the SD-WAN has dropped off those, has put that device into. And then, of course, it's very simple, right? We just advertise those routes as normal over to the branch. So that is an option. If there's some complication or concern about doing route import export, or you don't have the added complexity there. And then, of course, in the reverse, it's exactly the same, right? So the branch 2 would advertise its, let's say, 10.20.1.0/24, would advertise that back over, and then that would go over here to the DC core. And then, of course, the DC core would advertise it to the non-SD-WAN router, which would advertise it to our MPLS cloud, which would advertise it over to our legacy site. So that is another option if you don't want to deal with the import export. If there's policy reasons why we would not want to do route import export, this is a very viable option. And now from a BGP perspective, we only need to peer. So we've got the SD-WAN routers only need to peer with the MPLS cloud in order to advertise its connected interface. So that's just for the ability to establish IPsec. So it would advertise say this router had I don't know 198.19.11.5 or something like that. So it could advertise that to the MPLS cloud only, and of course receive. Well, actually, we have a couple of options here. So it could potentially, say there's a router here that was also connected to the MPLS. So it could also receive the advertisement of the other end's interface for the purposes of routing IPsec packets to build the tunnels. Or one of the other options is it could simply advertise its own interface, its own prefix, and then maybe only accept a zero route from the MPLS. Or more likely, because it's pretty rare that a zero route would come from the MPLS. More likely, what would happen is you'd set up some kind of a static default route, and then for that transport, and then only have that, use that, and then you would advertise the endpoint, because if you don't advertise your own endpoint to the MPLS cloud, the MPLS cloud isn't like the internet, right? Like it's only going to advertise and take the routes in that you send it. So while we can say DC SD-WAN 1 could say IP route 00000, next hop is MPLS, and that would be enough to send the packet. When it got to the MPLS cloud, of course, is really just the MPLS VPN and is only going to know about the routes that you send it. So while you can, send all your packets to the MPLS, you need to also make sure that you're also advertising the endpoint interfaces, IP addresses for each of the routers that are going to have connectivity to the MPLS in order to do the IPsec. That's different from internet, where, so generally speaking, of course, a public routable internet address, your provider is either giving you the IP or you've got some kind of provider independent space that you're already advertising to the provider. And, then the provider, of course, is going to be able to route it for you. So slight difference there. So again, we'll dig into this a lot more when we start talking about this specific use case. And I want to get some other design engineers and get their opinion and their thought about it. All right, so let's move on to the next topic. As huge a topic as the data center interconnect is, it also requires a lot of upfront understanding of how the data centers operate, basically. Do they operate active-active? Are they standby? Like, there's a lot of questions that need to be understood about the workloads of a data center before we can even start thinking about the design of an SD-WAN as pertains to how data center prefixes will be advertised, how loops will be prevented if they're redundant or active-active or something like that. There's a lot that's going to go into this. And so I'm just going to hit kind of the high notes here in terms of what are some of the questions we need to answer before we can even have a discussion about the SD-WAN. So what is the steady state workflow? Meaning everything's up, everything's working. What is the normal workload of a data center or pair of data centers, or however you're doing it, right? So is it a primary backup where we've got most of the virtual machines or servers or whatever workloads running out of one data center and the other's there for DR? Or is it active-active where we're load balancing some applications, some virtual machines, some servers between the two? Is there a need for them to talk to each other, under the normal steady state workloads? And, what about failure scenarios? So what about non-steady state? What is the DR strategy? If one data center dies, what is the failover strategy and what is the workload going to look like in that failure scenario or multiple failure scenarios? These are some of the stuff we need to think about, right? So because, if we have multiple data centers with a DCI of some sort, either a layer 2 DCI or OTV or a provider in the middle that we're peering with, there's so many options for DCIs. Where do we need to redistribute between routing protocols, if at all? And before we hit the WAN, right? Before we hit the WAN, once you hit the SD-WAN, you're using OMP, so there is a redistribution required. That's a given. But otherwise, what kind of redistribution do we need to see? And when we're doing redistribution, what do we need from a steady state and a failure scenario perspective? Like, what are we expecting the steady state routing to look like? What do we expect the failure state routing to look like? And how will the two support each other and support the business workloads that need to happen? And then, of course, my favorite is how complex is too complex. I like to joke with a lot of the other design engineers, and I like to compare, some of the frankly ridiculous failover scenarios that I've seen in the past with some people, some companies, where it's almost Rube Goldberg, like one of those dominoes type things where, you knock over a ball and the ball rolls and the ball hits I don't know, something connected to a string and the string falls over and, lifts up something that then goes down a slide. And you know what I mean? Like, it's like that, right? And the truth is, in almost every scenario, once you go past n+1, the solution itself becomes so complex that it would have been faster to resolve if you'd simply let it fail than try to troubleshoot the Rube Goldberg failure scenarios that have been built in. So important safety tip, Egon, don't cross the streams, but also don't make your failover scenarios so complex that if it ever happens, you will be troubleshooting the scenario itself instead of what's down. Like there is a use case or a business case for simply letting something fail and fixing it quickly rather than trying to keep it from ever failing at all and then having to support that level of complexity. So as an example, and this is not necessarily how things will look when we do the design, right? But I'm just, as an example from a visual perspective, this is one possibility of how you'd have to answer these questions and figure it out. What if we have two data centers and we're running BGP across the DCI or with a provider, and then we're running OSPF inside the data center, and then of course from a WAN perspective between the data centers and all the other branches and whatnot, we're running OMP. You can see where this could very quickly become a routing loop. The more times you redistribute, the less visibility and the more fuzzy the logic is for understanding how metrics are and which way we should go and different administrative distances, and things just get very ugly very quickly. Now, in this case, given this diagram, for example, one of the ways we could simplify this, and hang on a second while I switch over to my pen. One of the ways we could simplify this would say let's say we could take out the DCI peering with a provider. Maybe we have like layer 2 fiber or something like that, some dark fiber scenario or whatever. Let's say that was an option, right? Like, so obviously here we would just peer whatever routing protocol we're using in the data center. So we scratch that out, and it could be OSPF. And at least then you have contiguous routing protocol, on the back end, if you will. Like, that's an option. Or let's say you still had to have the DCI. Let's say this DCI still existed, but you didn't do BGP. Let's say your provider, you had to peer with them, but your provider would do OSPF or whatever routing protocol, EIGRP, RIP, I don't know, whatever, right? The point would be to keep it contiguous here to provide that resolution. And by that I mean not the resolution like fixing a problem, but resolution of the specificness of what's going on. You're not losing your metrics, you're understanding the routing, and you're not kind of making things fuzzy by redistributing here. So that's an option, right? So that could be an option. Let's say we didn't have that option. Let's say our provider only provided BGP, something like that. Well, then we still have problems, right? So now we have to go from OSPF to BGP, BGP back to OSPF, and then when we get the WAN, we have to redistribute to OMP, and then we have to be aware that, hey, wait, that those routes might come in on the other side of the data center, on the other data center rather, and get redistributed back in OSPF. So we have to figure out how do we break that routing loop that might occur, because most of your routing loops come from redistribution when you lose the resolution of the metrics and stuff like that. So that's just another thing to think about. All right, let's move on to the last one I think I have here. Okay, so Inter-VPN routing. You might have noticed on the original diagram that one of the branches was in VPN 20 and all the other ones are VPN 10 rather. So when we talk about inter-VPN routing, remember that we're talking about VRFs, completely different routing tables, completely segmented. How do we provide connectivity between them? So we have a few options, but first let's understand basically how it works. So from a high level, of course, every router is going to advertise the route to the vSmart, and the vSmart is going to be the route reflector that's going to make all the decisions. So this comes back to policy. When we talk about the vSmart, we're talking about policy. So by default, two VPNs are not able to communicate with each other. That's normal. So let's say that we this is in VPN 20 because it's a new acquisition. Say this branch was some new acquisition. We bought, Pop's Diner and their chicken and waffles establishment. And so this is a brand new addition to Cletus's Chicken and Waffles empire. So we want to keep it walled off until we can complete our acquisition and our making sure that they conform to the corporate security policies, that they have the correct, just everything is done right, and we're allowing them to talk to the rest of the network. So there's a need there to keep them separate for a while. But we do need to have some kind of connectivity. Maybe they need to be able to reach the corporate DNS servers, internal resources, to support the transition. The rest of the chicken and waffles recipe, whatever it is, right? So everybody's going to advertise the vSmart, and then the vSmart policy is going to have to be written that does very similar to what we talked about earlier between VPN 0 and VPN 10. It's going to be a route import export. So import export. So here we're going to import export between VPNs, between service VPNs. So, this of course will advertise its service route to the vSmart, and these guys will do the same. And then the vSmart will look at the policy and say, which routes should I allow to be leaked, more or less, between VRFs? So we could do an aggregate. We could do a stat. There's a lot of options, right? We could do just, usually what you'll end up doing is something just like an aggregate route, but if you wanted to, you could import every route. Whatever, it depends on what you need to provide connectivity bidirectionally or to. So there's probably not much of a reason for, say, this branch over here to talk to this branch over here as part of the acquisition. So we'd probably want to filter out those routes from being imported into VPN 20 as an example, and vice versa. So you can see it all comes back to policy. We have to figure out who needs to be able to talk to who. And again, for those that are familiar with MPLS Layer 3 VPN and BGP route reflectors, and this is going to look pretty familiar. Okay, so I think I've covered all the use cases I planned to think about with this lab. I'm certainly willing to take suggestions if anyone wants to see other use cases that the lab will support, basically, that we could add that make some kind of sense for the topology that we have. And let me bring up that topology one more time and we'll close out here. Okay, so again, this is the lab setup. If there's a use case that I haven't talked about that you'd want to see, certainly leave a comment below. And otherwise, I'll just kind of try to step through each use case. I would love to be able to do each use case with a fellow design engineer and just have a good conversation about it. I'm sure that they can bring stuff to the table that I haven't thought about. And just honestly, having good conversations about this sort of thing is just really important to the design process. Designing in a vacuum is kind of a pain in the butt, and everybody comes in with their own biases and opinions, and so being able to compare designs and talk through it really helps the design process. So again, thanks for watching. I hope it's been helpful, and I'll be back with digging into specific use cases as soon as I can put that together.